Welcome to BugNoJutsu, the place where coding becomes an adventure and algorithms get the anime treatment. In today's video, we're tackling a deceptively simple string problem that quickly becomes mind-blowingly recursive. We'll take a string that starts with a single character A and grow it using a transformation rule until it becomes long enough to find the kth character. It might sound easy at first, but as the string evolves, it explodes exponentially. We're going to walk through examples, dissect the transformation logic, and explore how to think about time and space in such growing simulations. Whether you're preparing for coding interviews or just love solving creative problems, this is one you don't want to miss. Let's dive right in. So here's the actual problem. We begin with a string A. Now, in each step, we create a new set of characters by incrementing each character of the existing string to its next alphabet letter. Then, we append this new set to the end of our current string. Let's break that down. In step 0, we start with A. In the next step, we look at the current string A. And for each character, we find the next letter in the alphabet, so it becomes B. We add this B to the end, giving us AB. Now this process continues. For AB, we generate BC gives us AB plus BC equals ABBC. Then ABBC becomes ABBC plus BCCD equals ABBCBCCD, and so on. The string keeps growing, based on transforming every current character into the next alphabet letter and appending that result. Our goal? Once this string reaches at least k characters in length, we want to return the kth character, one based index. It's a clever blend of recursion-like generation and pattern expansion, with a sprinkle of string manipulation. Let's now understand the logic behind this solution. Without jumping into code, we begin with a string word initially set to A. Now, as long as this string is shorter than k, we keep applying our transformation. We loop through each character in word. And for every character, fits Z, we wrap around to A. Otherwise, we just convert it to the next letter in the alphabet. We collect these next letters in a temporary string, and then append that to the original string. This continues until the length of the string is at least k. Once we hit that, we simply grab the kth character and return it. It's essentially a simulation-based approach. We simulate the expansion of the string using basic character manipulation, and we stop early, as soon as we have enough characters to find the answer. This is a very beginner-friendly yet insightful solution because it teaches you to think in terms of string growth and how to manage it efficiently. Let's analyze how efficient this approach is. Time complexity. Every round, the string nearly doubles in size. Because for each character in the current string, we're adding one new character. So after 0 rounds, 1 character. 1 round, 2 characters. 2 rounds, 4 characters. 3 rounds, 8 characters. And so on. So the total number of rounds is log k base 2. But in each round, we loop through the entire string so far. So, total time equals OK, in worst case, since we may build up to k characters. Space complexity. We're storing the entire string until it reaches size k. So space complexity is also OK. This works great for small to medium values of k, like up to 10 power 5. But if k becomes very large, like 10 power 6 or 10 power 7, this approach becomes memory heavy and might slow down. It's still valid, but there's a more optimized version possible, which simulates only the required transformations without storing the full string. We'll cover that in a future video. This problem might look simple on the surface, but it teaches us several powerful lessons in computer science and coding interviews. First, it introduces the idea of recursive string expansion. Second, it emphasizes pattern recognition, seeing how each round is related to the previous one. Third, it teaches us the importance of stopping conditions, knowing when to halt simulation. And finally, it shows how you can solve complex-looking problems using only simple character manipulations and loops. If you're preparing for interviews, this kind of problem gives you a strong foundation in string building, ASCII character arithmetic, space optimization, and simulation control. And best of all, it requires no fancy data structures or advanced algorithms, just a clear understanding of the transformation rule and loop management. That's why this is such a fantastic problem to include in your learning journey. And there you have it, the complete breakdown of how to find the kth character in a recursively generated string. We started with a single a, watched it grow into a chain of transformations, and learned how to simulate the process efficiently, all while preparing our minds for more complex algorithmic thinking. If this video helped you understand the problem deeply, make sure to like, subscribe, and share it with your fellow coding warriors. Also, drop a comment and tell me, what was your favorite insight from this video? This is at BugNoJutsu signing off for now, but I'll be back with more mind-bending problems, anime-related content, and fun coding tutorials. Until then, keep coding, stay curious, and never stop debugging.